To determine the resistivity, how we can work out the resistivity. So the formula, we have the formula R equals, the formula which relate resistivity and resistance R equal rho L by A. So we want to determine this rho, which is called resistivity. So that is RA divided by L. So practically how to determine the resistance? Resistance we cannot determine directly. There is a instrument which is known as the ohm meter, but ohm meter is not 100% accurate. So for more accurate result, we use the ratio between voltage and current, because the ratio between voltage and current will give us the resistance. So if we have a sample of a wire, we will connect a voltmeter, and then we connect an ammeter, and then we connect a variable supply. We'll change the voltage. So using a voltage and the current, we'll change different voltages and currents will be there. So we'll have different sets of result, and the ratio between the voltage and the current will give us the resistance. So we'll have the resistance. How to get the area of the wire? Area of cross section of wire. So area of the cross section of wire, A equals pi r square. So area is equals to pi r square, and same way we determine for a wire. First we'll determine its diameter. Using a micrometer, we'll determine the diameter of the wire, and from the diameter we'll get the radius, because half of the diameter will be the radius, and using the radius A equals pi r square, we'll get the area. So we'll have area as well. And how to measure the length? The using a meter rule or a meter scale, we can determine the length of a wire which we are using for the experiment. So we have all the parameters. Using this we can work out the resistivity of this material. Resistivity means how much resistance is there, resistance of a wire which is having a length of 1 meter and area 1 meter square. So as you can see here, using a crocodile clip, we measure, and the length here between the two crocodile clips, we measure the voltage, current and area of cross section of wire. So we use the formula R equals rho L by A to determine the resistivity. Is it clear, this experiment, how to work out the resistivity of a wire? Any doubt in this? Then the last experiment, which is investigating the EMF, electromotive force and internal resistance of a circuit or internal resistance of a cell. So how we can work out the internal resistance of a cell or battery, even a solar cell we can mention. So first we connect a voltmeter in parallel to the cell, and the switch is open. So V is there, the voltage, and I is there, the current. Now what we will do, when there is the switch is open, there is, and in the beginning remember that this is having a very high resistance. The variable resistor at the start of experiment is having a very high resistance. Now when the switch is open, there is no current passing through a circuit. If there is no current passing through a circuit, so internal resistance, because the battery is having internal resistance and external resistance R is there. But because there is no current passing through a circuit, so there is no voltage drop internally. All the voltage will be there, same as the EMF of the battery. So when the current is zero, the voltage will be maximum. So we'll start with a maximum value. Then what we do, we now switch off, we now connect this switch, and resistance is still high. When the resistance is high, the current which is coming out from the battery is low. So when low current is there, current I which is coming out from the battery, that is low current. So as a result, because the voltage drop across the internal resistance depends on IR. R is constant, so it basically depends on the current I. So if the current is low, it means the voltage which will drop here will be low voltage. So as low voltage or less voltage will drop here internally, smaller amount of voltage will drop internally. So the reading, because voltmeter will record not the loss voltage, it will record how much left. So total EMF example, if it was 3 volt and 0.1 volt is drop across through this resistor in across the resistor. So what voltmeter record? Voltmeter will not record what is like 3 plus zero point 0.1, because 0.1 is lost. So what voltmeter record? It will record 2.9. So if originally it is 3, but now it will become 2.9. Then we gradually reduce the resistance. We decrease the resistance. As we decrease the resistance, the current start to flow. As the current start to flow, so here it will be 0.2 volts. Then remaining 2.8 volts will be here. So what the reading on the voltmeter start to decrease. Then we further decrease the resistance. So current increases. As the current increase, more voltage drop internally and less voltage drop externally. Like EMF remains the same 3, but the voltage which is recorded by the voltmeter is a difference of how much is lost from the total. So it will record 2.5. So the reading on the voltmeter start to decrease as the current is increasing. When we join these points, the y-axis, when we draw a line, the y-axis, the y-intercept is known as the EMF of the battery, and the negative gradient minus R is equals to internal resistance. So when we work out the negative gradient minus of the gradient, that will give us the internal resistance of this cell. Is it clear, this one?